Our next speaker, Jim Cowan, is a professor at Louisiana State University. He's on the Gulf of Mexico Fisheries Management Council's Scientific and Statistical Committee. He just told me that he's also a member of their Ecosystem Scientific and Statistical Committee, so I'm interested in hearing about that. And also, he was recently a part of a group that put together an NRC report, a very good one if you have a chance to see it, for what work we're doing here. It's called Dynamic Changes in Marine Ecosystems, Fishing, Food Webs, and Future Options. If you haven't seen it, he asked me to mention that he's got a PDF of it, even though the NRC wouldn't like that to be known. But if you're very quiet, he might give you a copy of that. So, please.
Thanks. Well, let me begin by saying that I'm not going to talk about anything that Karim said I was going to talk about. And in fact, I rewrote my entire talk last night based on some of the things that I heard yesterday. So what I am going to do is try to provide some thoughts about perspectives that range from thinking about very sort of local effects on fisheries ecosystems to, let's assume that we are now expand the thinking to the U.S. Gulf and then the whole Gulf, and there are different issues related to implementation of management, ecosystems-based management, depending on the scale of operation that you're considering. I do want to put a little bit of, thought this would work. Can I back up? Well, forget about it. I don't even remember. I don't even think there's another slide in between there, actually. One of the things, the important thing is that the Gulf of Mexico, in and of itself, is a very productive ecosystem. It's by commercial landings in U.S. major ports, and this is in 2003, it represented a very high fraction of U.S. landings. And the area that we're talking about here is the north central Gulf, which has been called the Fisheries Fertile Crescent by Gordon Gunner starting back in the 60s. And a lot of the landings, both by value and by pounds, come from a small area of the Gulf that's influenced directly by the Mississippi River discharge, and that also means that about 75% of the U.S. landings occur in the state of Louisiana. So what I'm going to do is, I've heard all these people talk about everything they know about ecosystems-based management. My students constantly chafe at me because most of my talks about are what I don't know about ecosystems-based management. And what I'm going to talk to you first about is what I don't know about fish habitat relationships in the Mississippi River ecosystem, and then I'm going to end up talking about what I don't know about ecosystems-based management, and then I'll leave you with, instead of conclusions, a set of questions. So I mentioned that Gulf now exceeds all the regions except Alaska in value of landings. This is a little bit old. This was a 2005 report. Since then, the landings of Panea shrimps have declined precipitously because of the price of imported shrimps, but it's still on the order of 400 to 500 million a year. And by weight, the Gulf menhaden fishery is one of the largest in the world by weight, certainly in the U.S. So you might ask what generates this productivity. Well, obviously, one candidate is all of the fertilizers and nutrients and things that are brought down the river and deposited on the shelf in the form of the Mississippi River discharge plume. And this just kind of gives you an inventory of Gulf of Mexico estuarine systems. And the one thing that I'll point out, there's a lot of things that the river does, but one of the things that's somewhat unique, this is a Gulf geosyncline that runs along here. All this land that's south of this line between Galveston and Mobile was built by the Mississippi River. And so it's actually a very complex system of wetlands. And if you actually look at the distribution of the vegetated area along the Gulf, you'll notice that Louisiana sort of stands out both with respect to the distribution of open water and to distribution of vegetated areas, simply because there's a very articulated system with a lot of edge and open water and estuarine system, and that is generally thought to be an important player in the productivity of the system, especially since a big fraction of the fishes that we land fishes and invertebrates that we land are actually estuarine dependent or estuary dependent, depending on what editor you deal with. So now let's just look at the system from the very sort of close-in view. 40% of the U.S. coastal wetlands occur in the state of Louisiana. It's about 15,000 square kilometers. But in this area, there's more than 80% of U.S. coastal wetland loss. And part of that is because there began a process after the 1927 flood in which most of the central U.S. was flooded by the river. There had been a process of channelization, leveeing and channelization of the rivers began. And what it's done is it's sort of disconnected all of this land that was actually built by the river from the river. And now all of the sediments and fresh water get deposited out here in very, very deep water and are lost to the system. So we have an enormous wetland loss rate problem here. We also have more than 70% of the species being estuarine dependent. So there's a disconnect there that I think is pretty obvious. So, is there a relationship between wetland loss and fisheries? Certainly in the public press, there appears to be. This is something that came out. This was a Louisiana Sportsman, came out a couple of years ago, called Paradise Lost, and the sub-headline here was, "As the wetlands go, so do the fisheries." And that's sort of the public perception, and I think that there's reason to believe that that may be correct. But there's an interesting conundrum that we'll look at here, and let's just look at the commercial landings data. This is the Louisiana landings data over the period of record, and if you look at, again, Louisiana landings are 75% of the landings in the U.S. Gulf. It does appear that there was a peak when you include Menhaden and a slow decline afterwards. But it turns out that the decline here is mostly, in fact, a regulatory change. I mean, if you eliminate Menhaden from the catches, and it was a regulatory change in the Menhaden landings, there was a reduction in landings of Menhaden, which by far is the largest by poundage. And if you look at the remainder of the fisheries, excluding Menhaden, there's actually been an increase through time. And that just really seems counterintuitive, given the problem I just mentioned about wetland loss. So why aren't landings decreasing? Well, good grief. I love Windows Vista. Contributing factors. This is from a paper that I had recently just come out. It was part of the Moat Symposium in 2007, and I have a PDF version of the paper if anybody wants to read it. But I talk a lot about contributing factors, and you'll notice that I have here wetland loss being obviously can be bad, but it could be neutral or perhaps even good. And a lot of the things like eutrophication, some of these things, climate change, can be on both sides of this. And that makes it complicated because it depends on where you are with respect to change. And just to give you an example of why wetlands loss can be a positive factor is this is a figure that's reproduced from a paper that was published by, in 1985, and I forget, Joan Broder. And she indicated that if the ratio of marsh edge to open water is an important factor in the value of estuarine habitat to juvenile fishes, then if you start off with a marsh that is in perfect condition and has essentially a habitat that is free of any open water, it's not so good for fishes. But as the marsh begins to degrade, that ratio of marsh edge to open water begins to increase and levels off at some point. And then when as degradation continues, you start to get to a point where the edge to open water ratio begins to decline, and you can see that there's a period during which marsh degradation is actually a positive influence on fish biomass. And so where we are with respect to this curve in Louisiana and in the Gulf Coast in general, we're not sure. If we're here, you know, we might have one view of the world, but if we're here, we may have a very different one. And many of those other things, like eutrophication, work the same way. Some increase in nutrients actually increases productivity. Too much, John Caddy has shown us, particularly in semi-enclosed systems, you go from eutrophy to dystrophy, and you fall off the edge. And in fact, we've already been determined to be, well, declared dead, I guess. This was a paper that came out by Pauly and Palomares in 2005, and this is a Caribbean with the obvious normal, this is mean trophic level index, and this is the Gulf and South Atlantic, and the Gulf landings pretty much dominate this because of the menhaden fishery in the Gulf. And our mean trophic level index is very low compared to other systems, and it's also declining based on the analysis by Pauly and Palomares. So the system was already, even at the beginning of the record, declared highly degraded and overexploited. I'm going to show you that I don't think that's necessarily true, but that doesn't give me a lot of, actually gives me more reason to worry than if it were true, in fact. But ironically, and I think Tim showed this in his PNOS paper, that ironically increasing landings can be a symptom of fishing down food webs because you start moving down the thing with higher productivity stocks with larger biomasses. So we can't discount. Now here's the, see there, this is the problem when you change a talk twice between when you wrote it the first time, and then I had some thoughts coming over here this morning and I changed it again. But let's assume that Pauly and Palomares are correct. And if they are, then we're talking about something that, well, there was before and there's now, and then at some point fisheries productivity was higher, and we really have kind of fishing and climate to blame. I added climate here because I think it's sort of like one of those things now you can't leave out. It's just required. But the thing here is that fishing is considered to be primarily responsible in that Pauly's worldview paper. And we talked a lot about tipping points yesterday, and this is the idea that we've gone through one, and now we're down here to the point where fisheries productivity is much less than it was before. So now we're assuming Pauly and Palomares are correct. So now I'm going to tell you what I don't know. Now I just told you what I don't know about habitat-fish relationships in the Mississippi River because of that long list I had of factors and all that stuff. And I can tell you that none of it makes any sense because we have a huge area of hypoxia on the shelf. We've got wetland loss, it's just like crazy high, and landings aren't decreasing. So, you know, that's not reassuring to me. That's actually quite scary. It would be more scary, it would be more reassuring if we did have effects that were measurable in response to the changes in the ecosystem. But the fact that we don't scares the crap out of me, to be honest. But let's begin by assuming that Pauly et al. Are correct. And so what do we do now if we want to try to restore the system? And restoration is something that hadn't come up very much. But from my perspective, and I'll show you why, restoration is a big part of what we're talking about in the northern Gulf or in the U.S. Gulf with respect to ecosystem-based management. This is just land loss rates in different areas of the coast, and you'll notice that the rates have declined in more recent years. They sort of peaked in the 70s. That's because all the easy stuff to erode, disappeared. So the loss is declining, but I'll show you in a second how much it's declined. And if it doesn't, it scares me because I'm living in Baton Rouge, 3 hours from the coast now, but it could be waterfront property in not that much longer. But if Pauly and Palomares are correct, then maybe fishing regulation can solve the problem. We can rebuild our fisheries ecosystem simply by reorganizing or rethinking our approach to fishing. And the idea being that if you did that, you might expect the system to change in a way as ecosystems respond to regime shifts, where they go from these alternating steady states that look pretty much like the previous steady state when they shift. But I'm a little bit worried because of the paper that came out in 2001 by Jeremy Jackson et al. In Science, where they talked about this thing about shifting ecological baselines. And if anybody doesn't recall the paper, this figure was in it. And they talked about human expansion and the effects of fishing, pollution, mechanical habitat destruction, introductions, and climate change causing altered ecosystems. And what it also suggested that if you actually had shifted the ecological baseline, restoration to anything like some previous condition could be quite a bit more difficult if these changes occurred from the top down because of human expansion than if the changes had occurred from the bottom up, like regime shifts often do. And so the question is, when we think about this in terms of Louisiana, one of the things that we've done, major things that we've done, is that we've disconnected the river from the ecosystem. Well, if we reconnect the river